You take a 6 times 1, you got a 6. And then you take a 6 minus 6, you got a 0. Then you're gonna bring in down 9 over here, and then for instructional, purpose, I think that you're gonna have a student do put on the arrow sign like this. So you have a 9. The next one, you get 6 times 1, you got a 6. So 9 minus 6, you got a 3. Now moving on to next place value, because this class we cover the content area for elementary school, so we need to talk about the decimal. So I think the next place value, you have put on the decimal point and moving down 0. So you have a 30. So therefore, you take a 5 times 6, you got 30. So the answer is 11.5. Do you have any question for long division?
What happens if you didn't take it to the other decimal place? If you just put the 3 over the 6 and then ended up with 11.5? You want us to do it in the decimal? Take it the
Yeah, I
next
want to
place?
do it. I want you to do decimal
Okay,
because
gotcha.
yes, because this class we not only do the whole number or operation, and we want to do decimal and fraction. So I want you to do decimal. Okay.
Okay, gotcha.
Okay. And this is also this method called a long division. But actually, this is another name called English method. English method, because United States used to be a British colony, so therefore we use this method. And then we use this method. This is called the English method. But actually, a lot of European countries they do not use the English method. They use another way. They use a different way. And then the weakness of this method is you just show the algorithm for student, that's okay. But the weakness is student always struggle with what's the first number I have to fill in. Should I fill in 1? Should I fill in 2 or 3? Something like this. So student always struggle with this. So you need to have a lot of practice with this, okay? So that's why we need to have an alternative way for students to learn the different method. Okay. Here is another method I like to introduce: scaffold method. Are you familiar with the scaffold method? Yes or no?
No.
No. No.
Okay.
No.
If no, that's
No.
yeah.
No.
Some of you yes, some of you no. Okay. Scaffold method is another way to helping children better understand. This method for long division is more focused on the procedurally, but scaffold method can cover for procedure, knowledge, and conceptual understanding. All right. So I think I want to use another problem like this. That helps you better understand the scaffold method. Then we can come back to that problem, okay? Like a 66, I want to divide it by 6. Now, scaffold method, according to scaffold method, SCAFFOLD, scaffold method. So are you ready for 60 scaffold method? Okay, so we will not say this is a 1, okay? We will say 6 times 10. So 6 times 10, how many? 60, right?
60. Mm-hmm.
Yeah, so you put a 60 there, right? But in the long division, just tell student this is 1. That's, yes. But actually, it's a 10. So you take a 6 times 10, you got 60. Is that right? So therefore, you subtract this, you got a 6. So next, place value. This one is focused on more place value. The next one, what's the place value? 10 or 1? Or units?
One.
So it's units.
Ones.
Yes.
Ones.
So actually, this is a 1. Yes, this is correct. This is a 1. This is this is actually is 1, right? But here, this is not 1. This is a 10, right? So 6 times 1, you got a 6. Subtract this, got 0. So therefore, according to scale method, you're gonna edit out the total for this. So 10 plus 1. So the answer is 11. Are you with me for this? Very
Yes.
similar to very similar to the long division, but this one is more focused on conceptual understanding. That helps children to better understand the conceptual. Does that make sense? Okay. So now I'm gonna go back to the problem we have. Okay. The problem we have is what? 69 divided by 6. So this time we will not say 1, we'll say 10. Does that make sense to you?
Yes.
Yeah.
It works.
So 6 times we got a 60. So we take a 69 minus 60, we got a 9. Is that right?
Yes.
So therefore next we can take a 1 times 6. Oh, we got a 3. Is that right?
Yes.
Then next, move on to next place value. That will be 30. Is that right? And actually it's a 3 point. If you line up for decimal point is right there. So that is a 3. Is that right?
Yes.
So next place value, we have a 10. We have 1s. What's next? It's a 10th, right?
Yeah, 10th. Mm-hmm.
Yeah, so there were 10th. So therefore 0.5, which is 5/10. And you got a 3 for this. Does that make sense?
Yes.
So therefore, we added up the total, 10 plus 1 plus 0.5, we still got 11, added to the total 11.5. And by doing this way, students will not struggle with what's the first number I have to fill in. They'll think about 10s and 20 and 30 and stuff, or does it make sense, close to 69? Does that make sense to you for scale method?
Yes.
I think that I personally I really like this method because this helps children better understanding the division. Okay, division. Okay. All right. So now this is a scaffold method, and then next. What about in the classroom we have? How about in the classroom we have a quick learner? We have a quick learner. Now the quick learner can do the quick learner way, right? Like you guys are college students, and you deserve a quick learner way, right? Yeah. So I think that's why I'm gonna introduce this for you. Okay. Again, I'm gonna start with I'm gonna start with number is the whole number, and then we can go back to decimal. Okay. 123 divided by 3. 1 enough or not enough? Enough. 1 divided by 3 enough or not enough?
Not enough.
No, not enough.
Not enough. Okay, so therefore short division basically is a lot of more like a mental computation because quick learner, get this, quick learner, they don't need to write a lot of things. They can arrive the answer right away. Okay, that's for quick learner. Okay, and you guys are quick learner. All right, and I'm proud of you, and you can do it. Okay, so yeah, so 1 not enough. Now can we move on to next place value? Yes or no? 12 divided by 3 enough or not enough?
Yes.
Enough.
It's enough.
Yeah, and then I'll put on 4 there. 4 times 3 is a 12. Is that right?
Yes.
Yes.
So we don't want to write it down 12 at all because this is a quick. You just write the answer. Okay. What about 3? 3 enough or not enough?
Yes.
Enough.
Enough.
Okay. The answer is 41. So you don't have to write a lot of things like a long division. You can just write the answer by your,
Mental math.
by mentor. Yeah. Okay. Can we do another problem? Let's do 1, 2, 3, 4, 5. 1, 2, 3, 4, 5 divided by 3. So 1 enough or not enough?
Yes.
Not enough.
Not enough.
No.
Awesome.
Not enough. Move to next place value. I'll put down the 4 there. 3 enough or not enough?
Enough.
Enough. Put on 1 there.
41.
Then 4 divided by 3 enough or not enough or not enough?
Enough.
Enough.
Enough. Okay, get this. And actually is a 3 minus
Mm.
4. 4 minus 3 actually is 1. Is that right?
Yes.
But for this method, actually this 1, we want to write it down here. Okay. So this is a invisible now. Okay. Invisible now. Now I put down 1 there. 15.
Mhm.
Did you see this? 15?
Uh-huh.
15 divided by 3, how many?
5.
5. So the answer is 4115.
Oh, that's fast.
Do you like it?
Yep.
Yeah, I like it because I don't need to write a lot of things right here. I can arrive the answer right away, right?
Mm-hmm.
How about this one? I'm gonna give you 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay. Can you take a minute to do this problem?
No.
And I know you can do it. If this is long division, you take forever. But short division, just like a lightning fast.
Mm.
Well, I wanna give you a couple of seconds to do it. Okay, try it.
Mm-hmm.
I think so. You're done, right? Good.
Mm-hmm.
Very good.
Yeah.
Very good. So that's the okay. Let's check your answer. Okay, that's a 4. Is that right?
Yes.
Yes.
That's a 1. Is that right?
Yes.
That's a 1. Is that right?
Yes.
Yes.
And then put on 15 there. Is that right?
Yes.
Yes.
So that's a 5. Is that right?
Yes.
Yep.
Now put on 2. Is that right?
Yep.
Yes.
Now with the 2. Is that right?
Mm-hmm.
Yes.
So 6. Actually,
6.
7 minus 6 is 18. Is that right?
Uh-huh. Yes.
So that would be 6. Is that right?
Yes.
And then that's 3. Yay! You made it. How you feel?
Very good. Thank
You are
you.
smarter. Yeah, you don't have to write a lot of stupid stuff.
True.
And I think that's kind of things that, you don't want to stick on one method and then it's not working student forever, right?
Sure.
You want to try to different ways, helping them, encourage them.
Mm-hmm.
That's why, mathematics is not only one single way. It's a lot of different ways you can help in children more confident to doing the problem. Okay, how about this one?
Mm.
Back to our 69 divided by 6.
Oh, that's easy.
That's easy now, right? You have a 1. You have a 1. Is that right?
Yes.
And then you put on 3. Is that right?
Yep.
And then you decimal point, 9 decimal point, 11.5.
Yeah.
Oh, division make it easier.
So fast. Yeah.
Yeah, division make it easier for students.
Mm-hmm.
Right. So actually this class, I'm gonna go over different methods. Because some of the method you learn maybe in the past is a good method, but some of you learn the method in the past is not good method because it's not gonna helping you to understand, right? So I'm gonna collect some of the information. What is good for slow learner, for everybody learner, and then some way like it is for quick learner like you guys, and you feel you're more confident for this. Okay. Problem number 3. 19 minus 513. Okay, many people make a mistake for the fraction problem. So in this review, I will focus on some of the teaching for fraction operation because your state content test, there is a lot of problem for fractions. There is a lot of problem for decimals. Because I got a feedback, when I had just one student just, finish their content test and then, oh, Dr. Lin, you're right. There's a lot of problem for fraction and decimals, right?
Mhm.
Yeah. Okay. 19 minus 513. Okay.
Mm.
Tell me, what is the first step you want to do? What is the first step you want to do this problem? Anybody?
Find the least common denominator.
Find a common denominator. Very good. But what is a common denominator?
What is it?
What
13
is a
times
common
9.
denominator?
Maybe 13
Oh,
times
something same on the bottom, is that right?
9.
But why we need the same on the bottom? Why?
Why do we need it the same at the bottom?
Uh-huh. Why?
I don't know that.
Yeah,
So we can subtract
that's why I
from
need
So
to
we can
review.
subtract the top. I
Yeah.
don't know why exactly.
Okay. And then I'm gonna tell you why, okay?
Mhm.
I'll move on this one. Actually, fraction, addition, subtraction is the same, okay?
Mhm.
1/2 plus 1/4. Do they have a common denominator? Yes or no?
Yes, 4.
Mhm.
No, I mean right now, do they have a common denominator?
No,
No.
right now, no, they don't.
No. Can we do this? 1 plus 1, 2 plus 4, yes or no? And then
No.
you got a 2/6.
No, that's not right.
That's a misconception, right?
Mm.
Right. So like a content test, the kind of give you this answer and then give you, explain, what's the wrong with students on today, what's the they make a mistake. No, it's not right.
Mhm.
Hey, it's a misconception. What about this? Can we say you need to tell a story, okay? So 1/2, can we say 1/2 a pizza? Yes or no?
Yes.
So pizza. And the other, a quarter is a quarter of pizza. Can we say a quarter pizza? Yes or no?
Yes.
All right. So if you say 1 plus 1, can you say this is a big one plus a small one, you get a 2? Yes or no?
No.
No.
No, it's not equivalent,
No.
right? So you cannot say this is 1 and plus this 1, I got 2. No, actually no. Get this. If I give you a pizza, I give you the larger one or small one, you pick out which one.
Mhm.
You pick a larger one, right?
The larger one, the 1/4, yeah.
you pick a big pizza, right? So
Mhm.
that is not equal, right? So that's why we need to have equal, okay?
Mhm.
Now here, I can make a common denominator, okay? All right. So here is, did you see? This is my magic pen. So everybody say magic.
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 Okay, magic.
Uh-huh. Magic.
Okay, I'm gonna do magic. Okay,
Magic.
magic. Did you see the magic?
Yes.
Oh, what did you see?
You added a line that made another.
I add a line. I gotta make a line bigger. I add a line there. What did you see? And then this is become a 2/4. And then this is still 1/4. So do we have a common denominator? Yes or no?
Yes,
So
very nice.
therefore, so now we can have a numerator plus a numerator, denominator, keep that is. So we have a 3/4. Does that make sense to you?
Mm. Yes.
Yes.
Very nice.
And that is the reason we need to have same, we have a common denominator in order to do operation. Does that make sense?
Mm,
Oh, okay.
Yes.
So if this doesn't make sense to you, we're gonna go back to here. Actually, yeah, okay. So we have to go back to here. Did you see it? We make a common denominator. So I take a 9 times 13, 13 times 9, make it as a common denominator, right? So you times 13 on the bottom, you need to times 13 on the top. Make it is equivalent. Does that make sense?
mm-hmm. Yes.
If you times 9 on the bottom, you need to 9 times 9 on the top. Make it equivalent.
Mm.
Equivalent fraction. So therefore, 9 times 13, we make it as a common denominator, 117 for this, and then 117 for that, and 1 times 13 is a 13. The other one is 4 times 5, 45. 13 minus 45, how many? It's a negative 32. Does that make sense to you for this problem?
Yes, yes.
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 See, the review for me and here for this, is not just focus on the outcome and final answer. No, I think I want to give you more conceptual understanding. That is more important, okay? And this is also the things you need to teach in the classroom, okay? You're not just teaching them the conceptual, procedurally. Sometimes the conceptual understanding is important, okay? Next problem, number 4. 8 divided by 2/3. What is the first step you want to do?
Mm. All right.
Multiply by the reciprocal.
Mm.
Multiply the reciprocal, right? Multiply the reciprocal, all right? So you times the inverse, which is 3 over 2. Is that right? So
Mhm.
therefore, you have 3 times 8, 24, and then over 2, and then actually is a 12. Is that right?
Yes.
Yes.
Okay, now the question is, many students, they have a question. How come we have a division and change it into a multiplication?
Mm.
You might have a question for this, right?
Yep.
You have division, all of a sudden multiplication.
Mm.
It's kind of a mystery.
Mhm.
You must have reason for this, right? Okay. So how about this? If we say 2 divided by 3 is 2/3, make sense to you?
Yes.
Make
Yeah.
sense to you?
Mhm. Yes. Mhm.
If we have a 3 divided by 5, I say 3/4 is 3/5. Yes or no?
Yes. Same thing.
If I say 5 divided by 9 is a 5/9. Yes or no?
Mhm.
If I have A divided by B, we can say A over B. B is not 0. Yes or no?
Yes.
Yes.
All right. So A divided by 2/3. This is A. This is a B. Is that right?
Mm. Mhm.
A is 8. Oh, just a second. A over B. Is that right?
Mhm.
General rule. Can we say this is 8 divided by 2/3? Yes or no?
I don't know.
B is 2/3.
Yes, you can say that. It's just more confusing.
Yeah.
Yeah, it's not confusing. It's just a number. Whatever is a fraction or is still a number, right?
Mm.
But if you say this, look, and if you want times or what, can make this as 1. If I times
Times 8.
inverse,
Oh.
and then I make this as 1.
Mm,
And then at the same time, I need to times the 3 over 2. And this one is equal 1. So that's why we change it into multiplication.
mm,
Does that make sense to you?
mm.
Okay,
I
so
understand.
now,
I think it'd be hard to teach.
well, because you'll be a teacher, so I need to give you the reason why. Okay, so a lot of textbook they miss this important step. They will just give you a rule. Oh, division become a multiplication, and student if a student is like a quicker learner, they want to know why. Then you have to explain. This is a reason why. Okay.
Mm.
All right. So that's the answer. I answer you how come we can divide become a multiplication because of this. All right. Okay.
Mm.
So that answer you the first question for this. Here, I want to answer you the second question. Let me see. A divided by 2/3, then our answer is a 12. Then the student might have a question for you. Teacher, I have 8 divided by something, and then how come the number is get small bigger? How come the answer is bigger? It's a
Because you're
divide.
taking
How
a
come
portion of the whole number. You're not dividing it by another whole number. You're dividing it by a portion of 8, like 2/3 of the number.
2/3 actually is a fraction. You're not divided by whole number. That's what different story, right?
Right.
So therefore, when you divide it by a fraction, the number can be a small, the number can be a fraction. When you do the fraction division, sometimes the number is getting smaller, sometimes the number is getting bigger, right? So therefore, we need to tell the story, okay? Telling the story is important, okay? So therefore, here is a story we can tell. A, can we say a pizza? Yes or no?
Yes.
So I'm gonna draw a pizza. 2, 3, 4, 5, 6, 7, 8. I have a pizza, right? I have a pizza. I want to share everyone 2/3. How many people I can share? So everyone have 2/3. So that's why I divided by 3 for each pizza. Does that make sense to you? Why I have to do each pizza is the 3 portion?
Yeah.
Because I want to say I have a pizza, everyone share 2/3, and how many people I can share, right? And I want to prove this to you. How come a divided by 2/3 I become a 12? Okay. Okay, are you ready?
Mhm.
Okay, ready? That's the first person I can share. That's 2/3. Yes or no? That's the
Yes.
second person
Yes.
I can share. 2/3. 3, 4, 5, 6, 7, and 8, 9.
You missed a third on pizza number 5.
Oh,
Mhm.
did I miss something? Okay, 5. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Oh, 12. Did you see 12?
Mm.
So I can share 12 people, right? So telling a story will helping children understand this concept, right? So now, interesting. 8 is a pizza. 2/3 is a pizza. 12 is a people. So pizza divided pizza is not pizza. Pizza divided pizza is a people. So that's why we have 12 people. Okay, does that make sense to you? Does that make sense to you for this problem? Yes or no?
Yes.
Mm-hmm.
Yes.
Very good. Next problem, number 5. 4.8 minus 6.2. All right. Many people make the mistake for this problem. 4.8 minus 6.2. And then many people do it this way. Oh, I want to take a minus 2, I got 6. And then I take a 6 minus 4, I got a 2. So the answer is a negative 2.6, correct or wrong?
It's wrong.
It is wrong. You cannot create your algorithm. Actually, when you do subtraction, you only have to do the way like this arrow sign. You cannot do a minus 2, 6 minus 4. No, this is an incorrect algorithm. Okay, only when you do like a 5 minus 4, you only can do this way. Okay, does that make sense? So that's why this is wrong. This is wrong. This is wrong algorithm. Right. See, that's why we need to do the pretest. Then I can see, analyze which problem you don't know, and then I need to focus on more. Okay. So this is a decimal. How about I want to do whole number? 4 minus 6. 4 minus is equal how many?
-2.
Very good. Negative 2, right? Then negative 2, can I tell the student for student? Let's say I have a $4 in my pocket. And then I want to buy expensive Starbucks, $6. I know this Starbucks is $6 right now. It's very expensive.
Mm-hmm.
Do I have enough money? I have a $4 in my pocket only.
Mm-hmm.
I don't have enough money for $6 coffee, right? So how much money I don't have enough? I don't have enough to do that, right? Now, how much money? So therefore, we have another way. We call it. This is in German classroom. They use a lot called a decompose. German classroom. They use a decompose method. Okay, they use a decompose method to helping children understand the subtraction. Okay. So how they decompose? 6. Can we decompose 4 and what number?
4 and
2.
2. Yeah. 6 can decompose 4 and 2.
Mm.
Now, why I have to do 4 and 2? Because I have $4, and then I have $4 enough, but I don't have enough. So subtract this. So I have subtract this and $4 minus 4. I don't have enough dollar for negative 2. So that's why I have a negative 2. Does that make sense to you? For decompose. Decompose. Okay.
Mm.
Can we do another problem? You can decompose. Can you take a minute? And you want to decompose this? And 7 decompose is a 4 and what?
3.
3.
3. So therefore, negative 3. Is that right?
Mm. Yes. Yeah.
Yep.
Yes.
Okay, I got you. Mm.
Yeah. So
Gotcha.
now this is yes. Can we go back to this problem? 4.8 minus 6.2. Can we decompose? Can we decompose this as a 4.8 and one number?
Oh, that's
6.2 is a decomposed 4.8 and one number.
1.4.
1.4. Yeah, you got it. 1.4. So
Mhm.
actually, let's say I have $4.80 in my pocket, and then I want to purchase a coffee is $6.20. How much did I owe the store manager?
140.
Yeah, 140. See, if it is to connect all the, the real world context, should be no problem for you because you know how to count the money. So it's negative 1.4. Does that make sense?
Mm-hmm. Yes.
Yeah. Yeah.
Can we do one practice for this?
Mm-hmm.
Give you another problem, and you want to say decompose, because
Mm.
decompose is a very good strategy for helping children their mental computation. Okay,
Mm.
so let's say I have a $5.60, and the coffee right now is $7.40.
Mm-hmm. 1.8.
Okay, it's a 1.8. Yes.
Mm-hmm.
So actually 5 point. I have this one. Yeah, I have enough, and this one I don't have enough. Right. So
Mhm.
therefore, this one, that's why we put a negative 1.8. Does that make sense? Okay,
Yes.
very good.
Negative 1.8. Yep.
Next problem. 7, 8 divided by 5. So we have a 7, 8 times. Because I already explained this to you, is right? I already explained this to you, right? So I can just simply just times inverse. Okay.
Mm-hmm.
So I can just times 1/5. So so therefore, 7 times 1 divided by 8 times 5. So therefore, we have a 740 for this problem. Final answer, yes or no?
Yes.
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 Yeah. Sometimes we arrive the final answer, we have to double check. You want to say, wait a minute, final answer?
Mm-hmm.
Yeah. I will always say to my student, oh, wait a minute. And that means that you need to reduce fraction, okay?
Mm-hmm.
Okay, so that's 740, that's correct, okay? Now, here is another misconception I find from the student. And you want to tell me this is correct or wrong, okay? Now, student do 7, 8 times 1/5, okay? And this is what she did. She cross multiply. Correct or wrong?
Mm.
Wrong.
Wrong.
Wrong. What's wrong here?
You can
You can
cross
do this.
cancel, but you can't cross
You can't.
multiply like that.
You can cross multiply, okay? You can't do it because this is a multiplication. So therefore, numerator has 10 times the numerator. Denominator times the denominator. Is that right?
Mm-hmm.
Yes.
But only equivalent fraction we can do this. So this is this is incorrect algorithm.
Mm-hmm.
Only equivalent fraction we can do this. So she kind of make a mistake because she does not have confused with the fraction multiplication and equivalent fraction. For instance, like 1/2, 2/4. Can we cross multiply? Yes or no? Now, if we cross multiply, we got a 4. Yes. We cross multiply, we got 4. So therefore equal. This is equivalent fraction.
Mm.
Oh, only equivalent fraction we can cross multiply, not fraction multiplication. Does that make sense to you?
Mhm.
Yes.
Yeah. Some of the answer I find, oh, somebody need to need to know the multiplication rule. Okay, it's not equivalent fraction rule, and the multiplication rule is different. Only equivalent fraction we can do cross multiply. Okay.
Mhm.
Next problem. Number 7. How many percent of 80 is 20? How many percent of 80 is 20? Okay. So usually when I have this problem, I would like to label, okay, this is a part or whole. This is a part or whole. Percentage, part or whole.
Apart.
How about 80, whole or part?
Whole.
Yes. 20, part or whole?
Whole. Part.
20, part, yeah. Because you have how many percent of 80 and you got a 20, right? So now, this is a picture I will show to you. This is a one of called a segment method. Now, segment method will really help student. They have a visual representation. So therefore, we have put on whatever percent in this here, and whatever number we put in this line. Okay, so 100% is a whole. Is that right? And then this one unknown, we don't know. We put on here. Now 80 is a part of whole.
Whole.
80 is a part of whole.
Oh.
It is a whole,
Oh.
right? So we put on here. 20 is a part of whole.
Part.
So
Part.
part put in here, right? So part. So x over 20 is equal 100 over 80. So we can use this way to finding out the answer. Okay, so x over 20 is equal 128 over 80. Okay. So now here is equivalent fraction. Now we can cross multiply to finding out answer. Is that right? So
Mhm.
we have 80x times 20 times 100, which is 2,000. So both divided by 80. So the answer is 25. So 25%. Okay. Now 25% right here. Wait a minute. Correct or wrong?
Correct.
Does that make sense for 25% like this segment? Yes or no?
Yes.
Oh yeah. If I answer the 25 as a bar right here, and we have a 20 for this, and we whole is 80, and we have 100. Yep. That's the
Mhm.
answer. Okay.
Mm.
So in this way, student, whatever percentage problem, they can taken care of easily. Okay. I think some of the textbook, I would say, like uh, Singapore math. Some of the school district they use the Singapore math. Now Singapore math in the United States is more and more popular because they show more visual representation, helping children the conceptual understanding, and then and then also everyday math. Some of the student, in some of school district they use the everyday math. They use
Yeah.
a more visual representation, helping children understand. So they are using the segment method sometimes, something like this. Okay.
Mhm.
All right. How about this problem? Can we do the similar way to finding out the answer? And then this is a part or whole. This is an part, right? And this is a part of whole.
All right.
This is a whole.
Oh,
That's a
And
whole
this is part of whole. This is a part, right?
part. Mm-hmm.
So which one we don't know? We don't know the whole, right?
The whole. Mm-hmm.
We don't know the whole. So therefore we have to figure out the whole, right? We have to figure out the whole. So again, we can have a segment like this, right? And then this is a percentage, this is whatever number is, and then part 100% is right here. And whole, oh, we don't know the whole, the number is, but we do know 80%. 80% is right here. Does that make sense to you?
Yes.
And part, okay, right here actually is 160. Is that right?
Yep.
But here, which one we don't know? The whole we don't know. So therefore, we still can set out the equation like this: 80 or 160 is equal 100 over x. Is that right?
Mm-hmm.
And then we can cross multiply. And cross multiply with the 80x, which equal 16,000. Because this one times this one. Can we divide it by 80 to finding our answer? Yes.
Yes.
Divide by 80 for both. What's the x? X is equal to 200. So now we have 200 put on here. Wait a minute, correct or wrong? We have whole is 200, and we part we have 160, which is 80%. Yes.
Yeah, that makes sense.
yes.
Yeah. You always double check the correct or wrong for this. Okay. Number 8, 2 and 1/5 divided by 4 and 1/3. Okay. What is the first day you want to do this problem?
Turn them, turn it into a
Mixed
Imperfection.
improper fraction.
Yeah, you have to
Mhm.
Okay. Change this into an improper fraction. Is that right? So we take a 2 times
Yes.
5 times plus 1. That's why we got 11. Right?
Mm-hmm.
And we take a 4 times 3 plus 1. That's why we get 13. Is that right?
Yes.
So next, 11 5 times, okay, inverse. So 3 over 13. So 11. So therefore, we have a numerator times the numerator, which you got a 33. Denominator times the denominator, with a 65. Final answer, yes or no?
Yes.
Yes, because we cannot reduce this one at all. So that's the final answer. Check mark. That means correct. Okay. Next problem, decimal problem, okay? Decimal problem. Decimal problem. Point 0.6 2 times 2.3. What is the first day you want to do this?
Multiplies the left-hand side.
So do you remember when you done this one, the teacher will say, "Wow,
sorry,
ignore the
right.
decimal point. Ignore the decimal point." Is that right?
Yeah, exactly. You start on the right side and you ignore the decimal point. Yes.
Ignore the decimal point. Then
Yeah.
you want to count the decimal point back, right?
Yeah. Mm-hmm.
So ignore the
That's it.
decimal point. So actually, you take a 6 times 23. Ignore the decimal point. Is that right?
Yeah.
So you 3 times 6, 18. Next, 2 times 6 is equal, 2 times 6 is equal 12. Yes or no?
13. Yes.
No.
No, you need a zero. You need to move over a
yeah,
space,
yeah, you need a 0. Okay.
a placeholder.
Sometimes the teacher says 3 times 16 is 18, correct, right?
Mhm.
And then teacher said 2 times 16, that's correct, incorrect. No, it's not 2. It is 20.
So,
That's why students have a misconception for the place value. So therefore, we have 120.
over. True.
And then
Yes.
the research says that, okay, research says that if a teacher focus on the placeholder 0, that will help you children better understand this concept because the place value. So 20 times 6, 120. That's why we move one place value. Does that make sense?
Yes. Yes.
So we add together 1, 3, and 8. Is that right?
Yeah.
Yes.
And we count the decimal point. Decimal point right there. So we count a 1, we count a 2. So we're counting back. So that's a 1 and then 2. So the answer will be 1.38.
Mm-hmm.
Does that make sense to you for this?
Yeah.
Yes.
Next problem. 8 divided by one number is 24. Oh, I think I already explained to you, right? Now, can you tell the story for students? You want to divide it by 8 divided by one number, a whole number or fraction right here?
Mm.
Would this number a fraction or a whole number? Tell me.
A fraction.
Very good. Now you learn it because look, the number is getting bigger, 24.
Mm-hmm.
Yeah, and this one must be a fraction,
Mm-hmm.
right? So we can set up the equation like a divided by x is equal 24 over 1, and we can cross multiply. Now cross multiply, we get 24x, which is equal 8, divided by 24 for both. So x is equal 1/3. Yes, so 1/3, yes. You have whole number divided fraction, the number get bigger, right?
Mm-hmm.
Now you can say, okay, I'll have 8 pizza divided by everyone want to share 1/3 pizza. How many people I can share? 24. So you can show 24 for student. Does that make sense? Right.
Yes.
Telling the story, okay, is important. I always like to find a story, connect to the real world, okay? You not just have them to learn the procedurally. Procedure sometimes does not make any sense to people. If you find a story that will help people understand the concept, teaching mathematics. Okay. Next problem, 22. What's the 22? Let me read this problem. Give a number between 150 and 200 that is divisible by 7. I think that many people doing just pick out a random number and then divide it by 7. Is that right?
Mm-hmm.
Try and error. Do we have a way to do this? Yes, we do have a way. Because this number is small, it's easy for you to pick out any number to do it. But if this number is not quite bigger or not an easy number, probably you cannot just pick out a random number. You can find the answer, right? So, do we have a way? Yes, we have a way. I take a 150 divided by 7. So I have a 2 times 7, actually is 14. Minus this, we got the 10 for this, moving down 0. And then we put on like 1 there, we have 7, we have a 3. Is that right?
Yes.
Now 3 remainder, what's the 3 remainder tell you? I want to add how many more in order to make a divisible by 7? You have a 3? You have a 3 already? You want to add how many more?
4.
4.
4 more. Yeah, 1, 2, 3, 4, 5, 6, 7. So yes, you add 4 more, you got a 7, which is more is a divisible, right? So therefore, 154 divided by 7, add 4 more, right? And then let's check. Let's check. If you don't believe, and then you, and is 14 is divisible. Does that make sense?
Yeah. Perfect.
Oh. Now next time, if I give you the larger number, or you can find easily, right? You not just pick out any random number, right? Is that clear?
Nice. Yeah. Yeah.
Very good. Problem number 24. 9.5 divided by 0.5. Just 9.5 divided by 0.5. Okay. So I would do this problem, move the decimal point, make it as a 0.5 as a 5. Are you with me?
Yeah.
9.5 make it is, because you move this one, you have to move at the same time for this, right? That's a rule for division, right? So here, many get this. Many students make a mistake because they work on here. They are struggling with where is the decimal point goes. Don't do that, okay? I will suggest you teach children, move the decimal point. That's a 5. Move the decimal point, 95. Make it nice and clean. Don't work on here. If you work on here, student, they do not know, decimal point right here or decimal point right here. They're confused. Start a new one. Start a new one. We can work on here. So 1 is 5, and then moving 5 down there. It can answer. We don't have struggle with any decimal point. So we got 19. And student always got answer. And student happy. Parents are happy. The teacher happy. Right?
True. Yeah, true.
Now, why we have struggled with the old method? The old method is not working.
Too confusing.
Confusing. Yeah. Confusing. Start a new one. Okay, start a new one. And I've seen many of you, like other problem like a 49, 50, you got a wrong answer because the decimal point you got it wrong. You don't know where to go. But now you learn this method, you'll always get correct. Okay?
Nice.
Start a new one. Okay? How about next one? Problem 27. Problem 27. If you pay $30 for a garment on sale for 40% off original price, what was the original price? What does the 40% off mean? Do you pay 40% or you pay 60%?
60%.
Yeah, you are not paying 40%. Many people make a mistake because you still stick on the 40%. So actually, can we rewrite this like we just did for the percentage problem? We have a 60%. Actually, I pay 60% of what is equal $30. Does that make sense for you? Now, can we can do the second method like this. Whatever percentage put in here and number put in here, okay? Or maybe this time is money. So I'm gonna put up money.
6%.
Okay, 60% is about right here. 100% is a whole, right? Now, pa, whole, pa. Okay, pa is $30. Do we know whole? Yes or no? We don't know. And then that is X. Can we say this is X? Yes or no?
Yes.
Yes.
So we have a 60 over 30, which is equal 100 over X. Can we cross multiply? So we have a 60X, which equals 3,000.
3,000. 50.
Then
100.
divide by 60 for this,
Mhm.
and X is equal 50.
50.
Does that make sense to you for this problem? Yes or no?
Yes.
Okay.
Yes.
Next problem. Square root of 169. Square root of 169. Does anybody have any idea why they call a square root? Why not a circle root? Why not a triangle root? Why not a rectangle root?
No,
No idea, right?
don't know. No.
Because we say square root, that means anything. If we have a connect with the square.
Hmm.
So what's the square root mean? That means we have a connect. Well, I'm gonna draw a square, and 169 is right here, and 169 little square right here. We have a 169 of this. Now square root, that means we're looking for the length of this, because it's a square. So that's why 169, we have to find two number because it's a square. Two number is exactly the same times each other.
Hmm.
So what's the number we can find 169 with two number can times each other is exactly the same number we can times each other. So therefore we find 13, right?
Mm-hmm.
Yeah. So therefore square root is a 13. That means what? Oh, the length for this one is 13. The length for here is 13.
Mm.
Does that make sense to you for the meaning for square root?
Yes.
Yes.
Mhm.
Well, teaching children meaningful lesson is important, okay?
Mhm.
Did you see this when my teaching is different from math department? Math department just ask you for all the outcome, the answers, right? But here, I'm focused on more conceptual understanding because we are teaching what? We're teaching school mathematics. We are not teaching mathematician. We are teaching school mathematics, right?
Mhm.
So that's why we need to tell a lot of different story for children, okay? Now, what is the least common number 38? Number 38, okay? Number 38. What is the least common multiple of a 9 and 12? So
24.
here you can see 9 and 12. So therefore, I can take a 9 times 1, got 9, right?
Mhm.
9 times 2, got 18. 9 times 3, got 27. 9 times 4 is equal 36, okay? And the other way for 12, 12 times 1 is 12. 12 times 2 is 24. 12 times 3 is 36. Oh, we stop here because I already find the least common multiple. And this problem, look, this is a good for the small number. We can do this way, okay? What about the most classroom in the in the U.S. classroom they use. This is called a prime fertilization method.
Mm-hmm.
The prime fertilization method, that means we need to find all the prime, okay? So 9, we can break it down 3 and 3. So which is a 3 square. Now 12, we can break it down 3 and 4. Prime, yes or no? No.
No. Mm-mm.
So we have to do it again. That would be 2 and 2, right?
Mm-hmm.
So therefore, 12, we have a 12 square times 3. And then for prime fertilization method, once we finding out all the prime number, first of all, we list all the prime number. So do we have a prime number 2, yes or no? Do we have a prime number for 3 for all, just list all the prime number. Do we have a prime number 2, yes or no? We have 2.
Mm-hmm.
Do we have a 3 for prime number, yes or no? Yes.
Yes.
And then the final step, we choose the greatest part. Choose the greatest part. So here we have a square. Put on a square there. Now 3 square or 3 or 3. Which one do we choose? We choose the greatest part. So we choose the 3 square. So therefore, this is a 4 times a 9, which is a 36. Does that make sense to you?
Mm-hmm.
Yeah. You can do either way. You can do this way, or you can do the prime factorization method. But prime factorization method, you require a lot of memorization. First of all, you have to find all the prime number, the first step. The second step, you list all the prime number together, okay? The third step, you choose the greatest part. For instance, like this one, you have this and this. What should I choose? I choose the greatest part, which is 3 square. So therefore, times each other for 2 square times 3 square. So answer is 36. Problem 39. 7a divided by 3, 4. So again, we times the inverse. So we have 7 times 4 divided by 8 times 3. So therefore, we have 28 over 24. Final answer, yes or no?
Yes.
No.
Oh, wait.
No.
20 over 4, no.
Yeah, so
Then
you
put it
have
over.
reduced by 4, that's why divided by 4, we got 7. Reduced by 4, divided by 4, got 6, 7, 6.
Mm-hmm.
4, 1, and 1, 6.
Mm-hmm.
Okay, always check the final answer. The final answer has to be a reduced fraction, okay? Next, what is the parameter of a figure A? What does the meaning for parameter?
Adding up all the sides.
Sides together.
Looking for the side, right? That's a parameter, right? So we have a 3 plus 4 plus 3 plus 4. So that is a parameter. And many people make a mistake because they need to give me a unit, okay?
Mm.
So actually it's a 14 inch. Or 14 inches square. Which one is correct?
14 inches.
14 inches, right? But why not a square?
That would be the area. Well, I mean
There
the
would be the
square.
area, okay? And then next, I want to explain this to you, okay? What is the area of figure A? What is the area of figure A? So I'm
Well,
gonna draw a
square
picture
inches.
for 3 by 4. Okay, 3 by 4, we have 3 by 4. So 3" like this, 4" like this. So area is like this. So answer is a 12 inch or inches square. 12 inch or 12 inches square. Which one?
So squared.
Square, because what? We're looking for how many little square we have right here. So we 1, 2, 3, 4, 5, 6, 7. Oh, okay. No, sorry. I need to have a 4. 8, 9, 10, 11, and 12. Is that right?
Mm-hmm.
So we have 12 square, little square. So that's why we have this. Students always make a mistake. But you have to, once you draw this picture, they will keep in mind all the time. Because we're looking for the square unit. That means area. That means inside of this. But versus of this, we are looking for outside. What is the length of this? Is different. That's the parameter. That's the area. Is that clear?
Yes.
Next problem, 45. So the area of a square is 144, 144 square inch, 144 square inch. So what is the length of one side? So we're looking for what is the length of this? What is the length of this? And then little square of this. And how many do we have? So we have square root 144, which is equal to number times each other is the same number times each other. We're finding out it's a 12 times a 12. So therefore, it's a 12. And then 12 what? 12 inch. Don't forget about the unit. Don't forget about the unit, okay? Number 49, 148 divided by 16. Okay, I want you to do it again. I want you to give you a minute to do this again, okay? Many people make a mistake of 49 or 50. Take a minute, do it again. Okay, all done?
Yeah.
All right, when you do this one, what did you feel? You struggle with the first number? What's the first number you to fill in? Is that right? So we are finding out the number close times 16 close to 148. So A times A is not close to 148. So therefore we take 9. Okay, we take a 9 times 1 or 9 times 16, which is 144, which is close to 148, right? And then we do subtraction. And next one, 40, and then move on to next place value, put on the 0 there. With 2 times 16, 32, and then 40 minus 32, we got 8. Moving down the next place value, put on a 0 there. 5 times the 16, which is equal 80. So therefore, 9.25. Did you get right for this time? Very good. Very good.
Yes.
How about next one? How about next one? Can you do it again for this one? Do the way I just told you. Start a new one. Once you move the decimal point, start a new one. Don't work on here, okay? Do the new method I just told you, okay?
Mhm.
And by doing so, you will get correct answer all the time.
Mm. 24. 2. Okay. 1, 2. Nope. 1. Well, that was faster.
Yeah, that's a faster and more confident and always get correct answer, right?
Yeah, it's nice.
Do not work on here. Once you move the decimal point, do not work on here. Because if you will confuse where the decimal point you want here or there, you don't know, right? But you want to start a new one. One, you make it as 105.6 divided by 8. So it's, it's 1, you get a 8, and then 3 times 8, 24, and then move on to 6 down. So you get the 2 times 8, so it's 16. So 13.2. Did you get it right for this time? Okay, very good. Okay. All right. I think this is the we are here for today. Okay. I complete a review. So if you want to have see the whole review, you can watch the video. All right. If the problem you still miss is not in here, you can watch the video, go back to the video to watch. Okay. You can learn, and otherwise, I mostly cover the things, for the most of people make a mistake. Okay. Yes. And then the rest of time, if you have any question you want to ask me, you can stay here. Okay. If not, we are here for today. And then next time when we meet, which is the next time we will do the post test. The pre-test will count your grade. It's just only for the university the information. University will collect a student the pre-test, see what's a kind of a assessment for the university record. So that's an assessment for your pre-test. This is the baseline you have, and then this is after taking this class. How much do you grow, right? You make an improvement for this, right? Right. So therefore, the pre-test will not count your grade, but the second one will count your grade. Okay, the second one will count your grade. And your first assignment is a problem kind of practice, a different form for this. Okay, all right. So you want to show me when you upload your homework to D2L, you want to show you not just give me the answer, you want to show me
The work.
all your work. Okay, you want to show me all your work. Okay, because sometimes I will see, oh, you already learned, the different methods, from this lesson. So I think I want to, I want all the homework. You need to show me all your work in order to get your partial credit. Okay. If you just give me the answer, I will not take it. Okay. So your first problem set already upload there. You can work on your schedule, whatever, and as soon as you finish, you can just upload to D2L. Okay. And next time we will do the similar test, for the next week. Okay. And I will find a time for you to do the test. Okay. So we are here for today. So if you have any question and you want to ask me, you can stay here. Okay. If not, all right. See you next week.
Thank you.
Thank you.
Thank you.
Thank you.
Thank you.
When is
Thank
the
you.
assignment due?
The assignment is due. Uh, I think that the assignment is every we meet every Tuesday, right? So before class, okay?
Okay,
Wednesday.
thank you.
Oh, so it's
Before class, every
every
homework is before class. You have to turn in. Like problem set number one, you have to turn in before five 5 p.m. Okay.
Nice. Okay, I have a question if you don't mind, Professor.
Yeah.
My name is Ratiba Dalis. How are you?
Okay. Yes. I'm good. How are you?
I'm good, thank you. So I missed like the first 3 minutes of class because my connection. Did I miss out on anything, or were you just going over the syllabus?
I go over the D2L with you, so I'm gonna just show you again. Let me
I'm sorry, I don't mean to bother you, but
no
I
no
want
no
to
no
show.
no. Yeah, yeah. The
Thank
rest
you.
of time just leave for student ask questions. So I want to share the screen with you, okay?
Okay.
Did you see it?
Yes, I see it.
Okay. So in D2L, I posted 3
Yeah.
complete review, okay? 50 items review,
Okay.
okay? So if you want to see, that's the first things I mentioned. And then the second things if you want to go over review the right here. And then the second things I mentioned about is we have the problem sets right here, so you can click the problem set and then do the homework. Okay.
These are the
And
homework assignments, the problem sets.
yeah, you want
Okay.
once you yeah, there's a problem set, will take you
Yeah.
to the problem set, do the homework. Okay.
Hmm.
And then next we go over the tentative schedule. This is a tentative schedule. Okay. Tentative
Hmm.
schedule for, so we will follow this, this today we're gonna talk about computational test, right? And then you have to turn in your syllabus concept form. If you already turn in, it should be no problem.
Yeah.
Okay. And
Hmm.
then next time, next Tuesday, we will go over lesson 1, lesson 2, and then we will, you have to turn in your problem set 1. But the same week, maybe Wednesday, find your convenience time, we will do the computational test. Okay.
Oh, okay. This
And that's
test
the
will
things
be
are,
like, it will be with you or it will be proctored? Like, do we have
well,
to
would be
have?
the similar problem. I just changed the number from today's review. Okay. Would be the similar for your pretest.
Oh, okay. Okay, I
Would be the
understand.
similar problem for your pretest. Okay. Just change the number. Okay.
Okay, I gotcha. One
Mhm.
last question, if you don't mind. So for the most part, I got only like 2 or 3 wrong. I think when your TA sent, from my last assignment. But what happens if, how you taught us the new methods, right?
Yeah,
And
yeah,
they're more funner and they're quicker and they make me
yeah, yeah,
feel better at
yeah, yeah,
math
yeah,
because I hated math. And I still do. No
yeah,
offense
yeah,
to you,
yeah, yeah,
math is not my thing, right?
yeah.
But what if when I do the problems, like show my work, it's still the old version because I'm very old,
It's
right?
okay. It's okay. Any
Okay.
method is work for you is okay. I mean, people
Yeah.
are using different method, but I'm kind of give you some idea, give you
Yeah.
kind of more choices
The only reason is
to
like sometimes I forget, so I'm naturally doing whatever I'm used to.
yeah, yeah, yeah.
So
That's
if I
okay.
don't remember the new method, it's okay that like it doesn't
It's
count
okay.
wrong
It's okay.
as
Yeah,
long
it's
as we.
okay. Yeah,
Okay.
but sometimes a new method will help you better
Yes.
understand. Okay.
And it's
Okay.
better to teach, like you said. So it's very
Yeah,
much
yeah,
better.
yeah. And when you present your lesson plan for the senior year, I mean, when you do the teacher education program, you need to
Okay.
not just you have to you sure you have that diverse classroom
Yeah.
and diverse way of doing this. Okay.
Yeah, I
All right.
understand. Thank
Thank
you so
you.
much for your time. Thank you,
Thank
Professor.
you.
Have a
Thank
good
you.
night. Thank you.
Okay.
Take care.
Good. Bye bye. Nikki,
Bye-bye.
what's your question?
Bye.
Nikki, Nikki, are you there? Oh, your microphone is not working. Yeah. Yes, the poster will come your grade, okay? The posters will come your grade, okay? And problem set number 1 is due before class, okay? So next Tuesday, before 5
Is it
p.m.
due?
Okay.
Is it due on Tuesday or Wednesday? Because our class is on Wednesday. So is it due on
Wednesday, sorry, it's a Wednesday, it's not Tuesday, Wednesday.
just
Our class
Wednesday
is a
before
Wednesday.
5 p.m.?
Yeah, yeah. Just like you in class, you turn in paper to professor. Does that make
Okay.
sense? So Wednesday,
Yes.
Wednesday. It's a Wednesday before 5 p.m. Is that clear?
Yes. Thank you.
Thank you. Thank you. Anybody have a question? All right. And Nikki, do you have any question here? Oh, I think so. Your microphone is not working, right? Yes, actually, your problem set number 1. Problem set number 1 is kind of extra practice for the study post test. Do you want me to show you the problem set number 1? Your problem set number 1 is actually the practice. Your problem set number 1 actually is your practice, okay? Well, actually, just practice the pre-test questions again. Okay, if you need an answer, I can send you the answers, okay? If you need an answer for your pre-test, I can send you, okay? Do you have any other questions? All right, thank you. See you next week.